Welcome to today's session. By the last class, we were exploring about EBS, EMI, and EFS. What we did yesterday is like we created some additional EBS disk and attached it to the EC2 machine, and then we did the mounting and the installation of these file systems. And we have seen how to take an EMI of a particular EC2 machine with the pre-installed applications and configurations. So when you create a new machine out of your custom AMI, you will have all the applications installed in it. And then we were exploring about EFS. It can be bounded to multiple AZs in the same region. So we have and finally we have seen the mounting of EFS in the EC2 as well. So the today's class is completely focused about the high availability and scalability. So you first have to get familiarized with these menus. First, the high availability instance. Um, if you have a particular machine in one availability zones, so there is some availability percentage is there. We usually we for any services in the AWS, we the value is like 99.99 percentage. Okay, I consider like 99.9 percentage. So in order for me to increase the high availability, if you take in overall in here, like how many minutes or seconds are there, so if you take the 99.99, so there will be some lag time is there. For sometimes the service is going to be down, that you have to cover for the production environment, because if you expect there is zero downtime on your application, you should go for high availability. So in the sense, instead of deploying your application particularly one availability zone, you will be deploying across multiple availability zones. So usually we know at least we have three availability zones in a region. So you have to deploy your applications uh, in different availability zones. So your availability percentage will be get increased. So previously when it got deployed in a particular availability zone, the percentage is like 99.9. When after you did this application deployment to availability zones, the percentage is going to increase, and now it will be like 99.99. So that is what we always call this as high availability. Scalability in sense, so you have an application and it is serving traffic for 100 users now, but when what will happen if it has to serve the application for 1000 users, your application has to be scale in sense your compute has to be doubled, your application instance has to be multiplied. That is what we call scalability. So the scalability means an application can handle greater loads for adopting. So there are two types of scaling is available. We have actually seen this in our initial classes, but I want to repeat it again. So vertical scaling instance. So consider in an EC2 instance running with T2 micro, we know it is running with 1 GB of RAM and 1 GB of core, 1 GB, 1 CPU core and 1 GB of RAM. I am going to increase that. That is what we mostly called vertical scaling to T2 instead of T2 micro into T2 large or medium something. So whatever you decide configuration, that is you needed, you will be do. We generally do this vertical scaling in the database. Okay, because we cannot have the horizontal scaling in in database. So always it is preferable to do the vertical scaling in database. So horizontal scaling in sense whatever you have like in you have T2 micro with one CPU core and 1 GB of RAM, but in addition to that you will be adding one more instance. That is what we call horizontal scaling. So high availability instance, you like as I told, you have application deployed in the first availability zones, you are going to deploy the same application in another availability zone. So your application even in case of any failures to that particular availability zone, your application will be available in secondary region, so it can serve the traffic without any issues. So so now the important part, so how we are going to adapt these characteristics into the cloud. So when it comes to cloud, so we have something called load balancers. So this load balancers, because I told right, I'm going to deploy my application in multiple availability zones. Consider in the screen you can see three missions, right? So consider it is deployed across the three availability zones, iPhone 1A, iPhone 1B, and iPhone 1C. So now I am going to place my load balancer here, because when I create an EC2 machine, you know it is going to give me public IP, and the public IP is associated only to particular to this machine, right? Only to this particular machines. So each and every time, I cannot change my public address in anywhere in my DNS or something. So there should be a common point should be there. So what we will do is like we will create a load balancer, and this load balancer is going to serve the traffic to the end EC2 instance. No matter how many EC2 instance I have, like 30 or 50 or 100 EC2 machines, you will be giving this elastic load balancer public IP at the DNS, and by using that you will going to access. So this elastic load balancer will take care of doing this health checks and everything for you. So why we have to use load balancer? So to spread load across multiple instances. We will see all the options by one. So when it comes to load balancer, so we can have a different targets here, like like your EC2 machine, or some ECS or EKS or Lambda, or whatever you think, wherever you can run applications in the cloud environment, you can deploy all them as a target for the elastic load balancers. So elastic load balancers will do the L check as well. What is this L check? Consider like your application is running on port number 80 or something. Okay, what this load balancer will do? um, this load balancer checks whether application is really running on the EC2 or not. If it is running, if the port signal is passed, then it will consider the machine as healthy. Then only it allow the traffic to get passed, because you have like a 10 to 50 instance, like EC2 instance. Some of the machines would have been gone down without knowing the reason for us. So those times we should not route the traffic to there. So this health checks will be performed automatically by this load balancers. So if any issues are there, it will let us know. It will mark it as unhealthy, and traffic will not be routed to there. So let me go here. Let I come here. So for in order for us to create this characteristics in the cloud, first what we should have is like we should have some target groups. Let me move on the slide. Hmm. So okay, first let me explain the types of load balancers that are available for us in the cloud. So in the cloud, when I go to this load balancer section, hmm, it actually in the EC2 only. You have to just click EC2 and then come down. You will see a load balancer section. Click the load balancer section and then go to create load balancer. And then you can see that three options, right? Application load balancer and network load balancer and gateway load balancer. So what are the difference between this load balancers? So there is something called OSI model. What is this OSI model instance? So it provides you like seven layers to like access any application when it started to run. Okay, so we call it like open system interconnection. If you let me this way is better. If you see here, the first layer would be like physical layer, the second layer will be like data link, the third layer will be network layer, the fourth layer would be transport, the fifth layer would be session, the sixth layer will be presentation, seventh layer would be application layer. So this is the final layer when you deployed your application and it started to run either in HTTP or HTTPS, right? Either whenever we see some web applications, we go to browser and then we click some, like consider any dot coms, like facebook.com, or so, like let me take Facebook, and then I go inside here. If you see here, if I copy this URL and then I paste it in another tab, then you can see when I click the facebook.com, it was just showing the domain names alone. It was not telling where in which um, protocol it has been running. When I copied and moved to another tab, you can see HTTPS has been added here. So this means this application is been running in the HTTPS port, um, and that is our final layer of application. Okay, so similar to that, if it is if you want to access some application inside your networking part, then the application you have to access the application either using the transport layer or the network layer. Okay, so that this is enough to explain on the OSI model. Let me come back to my come back here. See, application load balancer works on layer 7, which means HTTP and HTTPS. Network load balancer works on layer 4, which is transport layer, which is going to work on TCP and UDP. TCP, transmission control protocol, and UDP means user definition protocol. So, so what is this difference between an TCP and UDP? You can, if you ask me, it's like TCP. Um, so as I told, let me paint this. So you all wait. So consider this as my client. This is client machine or your local machine. So consider this is as my server. Okay, so when a connection has been established from client to server, so what will happen? So the connection has will be routed here, and then it will get the response. This is what we call request, and this is what we call as response. When this connection happens between the client and server, so in TCP you will be having the handshake means first it will checks the client checks whether the server is up or not, and then um, and then it responds to client and then saying is, yeah, the server is up and you can send the events that you want to send. So this event checks, this pairing check has been will be happen in TCP protocol, whereas in UDP protocol it doesn't happen. UDP protocol doesn't checks for any pairing or checks. So then whatever the event that you want to send from client, you can send directly. So that's the difference between these two protocols. But compared to TCP protocol, UDP protocol will be much faster. So if you like, I'm hosting a web application. That's why I'm always you will talk about HTTP and HTTPS protocol. When you go for internal communication between your application, you no need to create an HTTP because it is like exposing your application to the world. If you no need like of exposing your application to the internet, this application has to be because you consider like a higher architecture in any applications, like one business unit will be consuming another business unit endpoints, so it'll be like that. Okay, this only the main business unit frames will be we can see from the UI rest, we will just they will interconnected within their VPC in itself. So those times you will be using this network load balancers. You no need to create an elastic load balancer. So the main application will have the ELB. ELB means elastic load balancer of elastic load balancer layer 7, and there will be end user here is going to access your ELB. ELB is going to forward traffic to your main application. Then this main application is going to talk with your network load balancer, which sits inside in between inside your VPC, and then it talks to some other business unit. That's how the functionality will happen. So, and the last type of load balancer is gateway load balancer. This gateway load balancer, um, it works on layer 3. So the layer 3 is the actual network layer. But what's the difference between this network layer and this gateway load balancer? It works on layer 4 and layer 3. Here what will happen is whatever the traffic that you receive from the client end will be evaluated. So your client sends some request, right? So here the user send in some request. What will happen before it entering to my VPC? Consider it as my VPC. Before entering to my VPC, this user traffic will be evaluated because this user could be some hacker as well. There's some they will trying to hack some information from my cloud, or I want to know what kind of information he sends, whether he is asking for like any unwanted requests or any unnecessary information he is trying to access from my internet. So throughout when it comes to like this gateway load balancer, we will filter out the traffic and then we send it to the cloud environment. So that's it. Mm, so let me we will create this load balancer soon in the last final class. So now let's come back to my PPT. So whatever the details I said, it's actually present here. So this load balancers can be public and private as well. Even the application load balancer, it not need not to be public always. So it can be as private as well. It's based on your architecture. Once we completed all these AWS resources, then we will see some architectural examples. I will give some certain scenarios and then explain why this architecture is better for this one. We will put all the microservice AWS resources and see what's a better practice that we have to follow in our cloud environments. Mm, and then the one more load balancer was there. It got deprecated now. It was the original classic load balancer. It's a V1 generation. It was there since the AWS created from 2009, but nobody is nowadays using this one. Even I didn't use this classic load balancers. Mostly people always stuck with using this application load balancer, network balancer. That is fine for any cloud environment to access any applications. Um, so see this how the routing is going to be. So so um, uh, so you can do the path-based routing or like domain-based routing. So we already seen some examples in our Kubernetes example. The path-based routing instance, you will have you have a domain name like example.com, and in this domain name, like for two endpoints, two application is going to run. So that is what, like if it is slash user, it has to be routed to one EC2 machine. If it is like slash host, it has to be routed to different machines. That is what we call path-based routing. Host-based routing instance, like we will have different domain names. For example, it has like example like one.example.com serves to one EC2 instance. Other.example.com will be served to other EC2 instance. So this is how the diagram is going to look. See, this www dot means internet. From the internet, you got a request under slash user API call. We have an application load balancer. In the end, we will create some target groups. What this target groups? It just an if you see, this is just an EC2 machine. This target groups going to be get covered. This EC2 instance. This target groups will do the L checks and maintain the EC2 instance that's available in the application load balancer. So there is not a much and much difference here. So if I go if I go for my target groups and then I create target groups, you see what are the in target type it should be. It is asking, it can support different kind of target group, just in layer. It just will be covering an type. The first type would be instance. So if you have any EC2 machines, you have to choose the instance the target type as instance. If you have any specific IP address, because this IP address can be sit somewhere in on-prem as well. Or some other AWS resources have some public IP that you want to function, and then if Lambda can be added as a target group, Lambda we will cover that, and then an application load balancer can be also added as a target group here. So I'm going to create an instance, and then I'm going to uh, give the target gives demo, and then I'm choosing the IPv4. So here you see the L check it as correct. One second. One second, there is some network issue. Hmm. So okay, okay, I'm back online.
Hello.
Yeah, some power cut was there, so that's why there was some network issue. I hope you can hear me now. So, while creating target groups, you choose the target type, and then you just name something, and then you choose the protocol. Uh, for the L check, you just choose the protocols where the backend has
Uh,
been running.
can you share your screen?
Oh, it stopped. Okay. Thanks. Uh, there might can again my internet can go down because generator is running now. Once again the power comes, it cuts. Just let me know. Okay. So
Sure.
I'm created started to create the target groups. So once the target group, I'm choosing the type as instance and I'm giving some name. So here after I giving the name, it is asking two sections: protocol and port. So on what protocol or on what port my application has been running. So you have to define that protocol for load balancer to target communication. So here you can see like a lot of protocols are there, right? HTTP, HTTPS, TCP, TLS, UDP, and everything is there. You can just choose whatever the protocol your application is going to run in the EC2 instance. You just select it, and then you select the IP address type IPv4 and V5, and select the subnet. Like let me. So if I choose my type as VPC, wait one second. Again, it's getting dropped off. If I choose the VPC as my default VPC and then protocol version is HTTP. So here in the last section, there is something called L check. So mostly whatever the protocol you choose for the target, that will be your L check. So this slash after the slash API call means after your public API, whatever the API call that is providing you some static pages, you just give that. So I know whenever I deploy some Apache application, slash after slash whatever the index.html file is, that is going to serve for or me in the internet. So I'm just going to keep it as slash here, and then if you click next, so here I don't have any EC2 instance, that's why it is no instance has been showing for me. So whatever the EC2 instance there for you, you just select them and then you create the target group. So that's how we create the target groups. So for this demo to uh, proceed, let me go back. uh, okay, it's connected. You can hear me, right, Lokesh?
Hmm. Yeah, I can hear you,
uh,
but I can't able to see actually.
okay, let me see. I think screen is still sharing, I guess. I hope you can hear me now. And let me share my screen back. Sorry for the issues. Um, so what I'm going to do now is like I'm going to deploy some EC2 instance and I will show the complete configurations. I will be using these target groups, load balancers, launch templates, everything. Okay. So for now, what I will do is like, so there is something called launch instance. Before the launch instance, um, hmm, what I will do, I will create a security group for my EC2 machines. So uh, because I'm going to, I know what kind of architecture I'm going to do now. So what I'm going to do is like I'm going to do similar kind of this thing. So I'm going to create some application load balancer and I'm going to create some target groups. First, I will be creating the target groups. So for this groups to be created, we need something called launch templates. What this launch template is? So every time when I create EC2 machine, it asks for me in which VPC it was to be deployed, what your storage size, what your AMI. So I'm going to pre-configure that as a template. So and then whenever a new machine is going to get created, I'm just going to use a template. That is what we call launch templates in AWS. So these target groups will be created from the launch templates, and then after I will create a load balancer as well. So what I will do here is like, let me go here in the instance, you will be seeing something called launch template. So where the launch templates already, I will delete this one. So I'm going to create a new launch template. I will call it as Phoenix uh, template something, and then I'm going to create it with version 1. So the advantages of template is you just select all your parameters, whatever that you need for EC2 machine, and then in the next time when you come, you can just revise the version. Now I'm naming the version as 1 year, template version as 1, and I'm giving the template name as Phoenix template. And then if you scroll down, you will see all the UI details related to EC2 only. So in the quick start, I'll be choosing the Amazon Linux, and then it choose to my AMI, and then the instance type should be T2 micro, and then I'm going to use key value pair AWS hyphen key slash one, so which I have already, and then I'm going to select the subnets. I'm just selecting the first subnet AP South 1A, where I want to deploy my EC2 machine, and then here in the security group I want to create a new security group, and I'm going to call it as allow HTTP. Okay, and then name it as EC2 SD. I'm naming it as like EC2 SD means security groups, and I'm going to allow HTTP. I'm going to add the security group. The rule is to like use HTTP. Source is from anywhere means 0.00. Okay, later we can edit this security group, no issues. Or I will do one thing, right? First I will create the security group here. So I will going to create new two security groups, one for my EC2 machine, one for my application load balancer. So what will happen here instance, so here I'm going to attach an like security groups. So and it will be allow the signals only from the security group of load balancer. So here I'm going to create two security groups. This security group is open from the world for any traffic of HTTP from throughout the world. This security group will allow the traffic only from the load balancer. So that is what I'm going to achieve now. So what I'm going to do is like I'm going to create a security group. First one is like ALBST, that means application load balancer security group, and then I'm going to allow HTTP here. I'm just giving some description, and it should be in the default VPC. In the inbound rules, I'm going to add rule, and then I'm going to choose HTTP, and then the port is to be 80, and it is fully open from the throat way, and then I've saved the changes because I'm creating the ELBSG. This ELB EST is open from the world. That's why I open HTTP port and I've given the 0.0.0.0. Now I'm going to create one more ST. Let me go to the security group. Now I will create one more security group. I will call it as EC2 SD. It is allow. I'm just giving a description, allow HTTP. So I'm going to create in the default VPC only, and I'm going to add an inbound rule. Same, I'm going to allow the same HTTPD, But instead of giving the throughout the world, if you like throughout the world means whenever I EC2 machine is created, and just by using the public API, I can able to access the machine. But I don't want in that such case. So if you scroll down, first you will see the CIDR option, next you will be see the security group option. Here I am going to select the ALBST. So the meaning of this like so this security group will allow only the traffic from ALB now. So and then I'm going to create the security group. Now if you see in my security groups, new two security groups are created. One is for EC2SG, one is to ALB security groups. If I go back to my launch template, now I'm going to create the launch template. So I'm giving it as an Phoenix LT. That means Phoenix launch template. I'm giving it as a version 1, and then I'm selecting in the quick start. I'm choosing the Amazon Linux, and then my instance type would be T2 micro, and then my key value pair is to like AWS hyphen key slash one. Subnet, I'm selecting the only the first subnet on AP hyphen south hyphen 1A, and then I'm selecting the existing security group. It was asking me security group, that's why I don't want to modify it at the end. That's why I created a security group. I'm creating an I'm going to attach an EC2 security group here, and then rest all the configuration going to remain same. So but I am going to deploy some predefined scripts. What I'm going to do is like I'm going to install the Apache here, and then I am going to update the index.html file. uh, Let me find the script here. So you can see what I'm doing in the script itself. I'm just doing the yum update, and then yum install httpd, and then I'm enabling and starting the httpd. But what I do is like I just host name hyphen I will give you the private IP of the machine. If you see the host name hyphen I, it's giving the private IP, and I'm saving that private IP in variable called local IP. So what I do is like I just print a statement welcome to my server, and then I'm updating that IP address to the to that in the echo command, and then updating all the echo commands into the index.html. This is the default page. Whenever you install httpd, you will be seeing some default http pages. Instead of the default page, I'm customizing my pages. Also what I do is like inside what this Apache will do after the installation, wherever it sees index.html file, uh, after like a slash where www dot and html, it will just what if it is finds any index.html, that will be displayed for you in the browser. So what I did is like additional to that, I have created two directories, creating like app1 and app2. So and then I'm like copying this index.html to those folders as well. So we will see what's the use case here. Let me And then I am going to launch the template. So this is just a template. It doesn't have to be get created. You see, it has all the metadata information, and it has been created. Now I will go to my target groups. Retry. Now I will create my target group. I will choose it as an instance because my backend should be EC2 now. Now I call it as Phoenix. Target groups, and the protocol is to be HTTP, and is running on the port 80, and the IP address is like IPv4, and I'm still choosing my default VPC. That is where my template has been. So and then if you scroll down what protocol version it should be, it still has to be like HTTP one only. So HTTP 2 means it is for some gRP services. So this is some kind of special kind of features in HTTP itself. Never mind this. Just choose your application now is going mostly. So we are mostly whenever a connection is going to happen um, inside your VPC, you will be using the HTTP protocol only because it's already in virtual private cloud. it's a virtual network and it is already isolated from the internet. Nobody is going to access your applications. So here all the applications should be, you should access with the HTTP protocol, or either with HTTP, or you will be simply using the TCP protocols. So whenever your connection is coming from the internet to your virtual protocol, that time only you should have some HTTP protocols in front of your load balancer. So now I'm just choosing everything as default, and I know my application is it's going to do L checks. That means when an Apache is started to run, it is in the default in the default endpoint, whatever the application is running, that is I'm considering as L check for me. And then I click next, and then it is asking me to select the available instance. So there are no available instance now. That's fine. Let me create this target groups. So my target group also is created, but in the target groups, no um, machines are associated now, right? So that's fine. Let me go to the load balancer now. So this is just an outer layer. It has been created now, and none of the machines are attached here. Let me go back to the load balancer, and then I uh, click the creation of application load balancer, and then I create it. So the first option is like load balancer name. I'm going to check it as Phoenix ALB application load balancer, and then it asks for me internet facing or internal facing. Internet facing means for you are you exposing this application load balancer to outside world, then it will be created with some public IP and all. When you go for internal IP, it is not exposed by using the it will get an IP from your VPC, and it is exposed, and you are able to access it only from the your VPC alone. So here I want this application to be exposed to internet, so I am choosing the internet facing, and then it asks a lot of options here. Load balancer IP, always try to use this IPv4 itself. So if you need IPv6, you go for this dual stack, and then you choose a dual stack without public IPv4. Mostly people should not be using IPv6, only in the complex data will start to use. Now just stick with IPv4, and then I'm selecting my VPC in by default VPC, and then it is asking me to choose the availability zones. So in which availability zones my load balancer, application load balancer need to route the traffic. I'm choosing all the three regions, because in all the three regions, if it is application deployed, my load balancer I want it to route the traffic. So I choose it, and then here in the security groups, I already created a security group for application load balancer, and it is receives the HTTP traffic from the web, and I'm going to attach that. And then it is asking the listeners and routing configurations. Here you choose the uh, here in the listeners and routing, and the protocol is still HTTP, and the port is 80, where I know my application is listener means um, uh, please watch it carefully. This is important one. Consider this as your ELB. This will have some DNS names or some public IP. Okay, this is your user. In which protocol or which port the ELB should be accessed. That is what we call listeners. So I know I want my ELB to be accessed in HTTP. I don't have any SSL certificates here, and it has to be on port 80. That's what this listener in means. And then we will be matching some rules, and in the backend only we call it as target groups. That is what we call target groups. We will perform some health checks here, uh, and then we will be mapping, creating different rules, because consider this is my target group one, and then the target group two will be there. So you can play around with different rules here, so that if it is like this domain, access the TG1. If it is like this application, access the target group. Those kind of rules we will going to configure. So you should be configure. You should know what is the listeners, yeah, on which protocol my application load balancer need to be accessed. and in the backend I'm going to choose the Phoenix-TG. So in the backend, what will happens? So now I choose the target group. So this target group still doesn't have any missions, but whatever the mission that going to create inside the target group, uh, that should be controlled by the application load balancer. Rest leave this all these advanced options. So we will come up to this again, and then you create the load balancer. That's it. Your load balancer has been created for you, but you know there is no EC2 machine has been created. For that, what you can do is like either you can create an like you create an like how we create an EC2 machines. You just from this launch template, whatever you have, you just choose a launch template and then you uh, launch instance from the template option is there. When you click, your machine will be get deployed. Okay, but I don't want to create my machine from the normal options. That is what we usually do, right? Is the template is there. If you latch and machine, easy to machine will be created, and your load balancer can serve the traffic from there. But I don't want to do that. There is something called auto scaling group is there. Okay, why I need this auto scaling group now? So you created some target groups, but there is no machine is attached, and then you created load balancer. The front end part is we call listeners, and the back end is we call target groups. No machine is attached. I'm going to create an auto scaling group. So if based on the traffic, it is going to scale for me. That is what we call seen in the scalability. So you go to these auto scaling groups and you create an auto scaling, and then I choose it as Phoenix TSG. So here you see the first option is like launch template. So we created a launch template, right? Phoenix-LT. So and I'm choosing the version 1 year. So all the uh, parameters that we made in the launch template, now the auto scaling group will be going to create the instance. You choose next, and then it is asking me for the networking and all. So I still choose the same thing. Um, I still choose the same VPC and the all the three availability zones, and then I choose the so these are the new options. You no need to worry about these things. You choose next, and then what it asks is like you see load balancing. No load balancer or choose from your existing load balancer. I know a load balancer has been already created, so I just what I made like attached to an existing load balancer. So if you don't need any load balancer, you choose the first option. If you have existing load balancer, so if you want to if you're going to create a new load balancer, you choose this last option. So each and every option you will have some description that you can read over on and then you can work on. So now I'm going to, it is asking me to attach to the existing load balancer. So I already have a target group has been created and I'm going to create add it as in Phoenix-TG. Now you see in the first step in the launch template, what happened? Uh, I just named my auto scaling group. Wait, auto scaling group. ASG, and then I choose my launch template, and in the second option second step I choose my VPC. In the third service I've integrated my target group here as well. So now see all the things which I created, it's getting associated. So I'm attaching to the existing one, and then Phoenix FNTG, and then L check is there. I'm turn on elastic load balancing with L check. I'm just choosing an L check whether you need L checks here or not, because uh, so now this target group is being controlled by AST. Uh, Now this target group entirely is going to controlled by AST, and the new missions are going to be get deployed here. But the one thing I want to do is to talk about is like this target group, what you need an L check, whether you need an L check or not. Because in the target groups, if any of the machine is getting failed, so by using this L check, previously we were seeing the L checks. That L check is purely for in the target groups also we have seen the L check. This L check is to like if you have two instances, it will check for the application is running or not. If it is not running, then the traffic will not be routed here. That's the use of this target L check. But in the AST, if it will check if the machine is not working, it will also do the L check. If the machine is not the application is not up on the particular L check port number, it will mark that machine as NLK and it will delete the machine and will create a new machine for this by from your launch templates. So that's the reason that we have L check here. I'm That's the meaning of this L check, and then I create it. And then so here we have something called decide capacity and min capacity and max capacity. Decide capacity in sense, so what is the number of machines that you needed now? So I mark it as 1, and then my minimum capacity is to 1, and then the max to be 2. So what the decided capacity means, what's the capacity of each two machine that you need now? So the and even based on the traffic, we are doing the auto scaling here. Let me check. I think I must be option 4. Here I choose an auto scaling policy is there, right? Here if you see in the minimum capacity, I choose the 1, the max is like 2, and then there is something called auto scaling policies. No scaling policy means that it will not scale based on the traffic. So when I choose this target tracking scaling policy, here you see there are in the backend it will take care all the functionality. You no need to do. You just need to choose the parameter average CPU utilization, network in and out, and then application load balancer request per targets. So by using these parameters you can scale. So what I want is like if my average CPU utilization on that particular machine is above 50%, scale one more machine. That is what the meaning of these things. And then you see something called instance maintenance policy. That means I told that if the machine is marked if the machine is marked as unhealthy, a new machine is going to get created. Launch before terminating, like that means you create the machine and then you terminate. You then there is something called terminate the machine and create, and then some custom behaviors. If you want to do the custom behavior, that you can control. So I'm going to choose the no policy here, and then I'm not going to change any of the default things, because if you had any reservations, you can reservation of the machine that you can choose here, and then I choose the next option, and then I click next, and then I click next, and then I'm going to create. Now my auto scaling is, so it's started to create. Let me wait for some times. Whatever I created launch template, I created load balancer, and then target group has been created. Now if you check my load balancer, um, if you check my listeners, so now if I go to instance section, let me refresh. Once the auto scaling group is created, now it will start to create a mission for me. Let me say it. Now you see a mission has been created and it is in initialization. Once the initialization has been done, we will be able to see the web page from the internet now. Let's see. Let's wait for the application to come up. Uh, it's still in the initialization phase. But fine. If you go to load balancer section and then you click that load balancer, you right check, you will be seeing multiple options here. So what I want is like I want this DNS name. You copy this DNS name and then you go to the browser and then you paste the DNS name and then you enter. Right now it's still not running. That's why you don't see. If you go to the target groups, if you click the target groups and then you see a target here, right? Here you see a machine is marked as healthy. So now it marked as in the target groups. So it is marked as healthy. That means it is ready to serve the traffic. If I do refresh again, mm, once again let me check. So in the inbound rule, I am actually allowing HTTP, TCP, 80 0.0.0. Here I'm allowing only from the 653. It has some public IP as well. Uh, listener section is default, and then it's mm, I think it's you can see, it took some time to get reflected. Now you see, I didn't do any changes. You see, now it is saying me, welcome to my server 172.31.14.234. If I go to my instance here, this instance has been created. If you check the private IP, it says 170.13, like it ends with 234. You see, it is coming from the server only. So I have a common point, and it is routing the traffic to this particular machine. So here in the load balancer, if you check, we have something called mm, wait, let's call up. We have some listener section, right? So you see a lot of details here, like some basic details, like what is the type. What is the load balancer type and schema and hosted and VBAR and the VP, which VPs is there, and the main section, and then what security group it associated, and then monitoring, like how many requests that you got, the rule evaluations, those things you can see. There is a number of sections here, like, and then the capacity of your load balancer, um, and then the main section for use like this listeners and rules. Because by using these listeners and rules alone, we will be hosting the application either in the path based routing or in the domain based routing. So right now I want to show you the show you the path based routing here. So here you see the listeners, it's opening on listeners on HTTP 80. So but what I want here is like I'm going to run two applications, and I'm going to access my first application under slash app1, and the second application under the slash app2. So for that I have to update my listeners as well. Before updating listeners, I will create one more target group. So let me go to this instance. Now what I want to do, I will do is like I will create one more instance from the launch template directly. So I will create an launch instance here. Wait. Uh, Launch instance from the template. So and then it is giving me, and I'm going to choose everything as default here, and then launch instance. So this time what I did is like there was template is already available, so I have uh, triggered a mission from that. Now you see second mission is been started to consider. I can name it as like new mission something. So in order for you to avoid the confusion, or like TG2 target TG2. Just for the differentiation, this is the first machine that is created by the auto scaling group. This is the machine that was created directly from the launch template. Now what I'm going to do is like I'm going to create one more target groups. Now I'm going to create one more target group. I'm going to name it as like Phoenix TG app 2. Okay, so I'm going to create as a app 2, and I'm going to follow the same settings that similar only what we followed yesterday. Just I'm changing the name. Here, there are two instances are available. I know this TG1 is already part of the auto scaling group which I created. Now this TG2 was created from the launch template directly, and I select it, and then include uh, when you select this include a spending below, it will be added as a target for this new target group which I'm going to create, and then I'm going to create target group. Now what happened is like uh, a new target this new target group has been created. If you go to my two target groups, this is the target group I created initially. Now the new target group has been created. If I go back to my load balancer, what I want to achieve is like I want to achieve similar to these things. If it is like slash app one, route my traffic to the first target group which I created. The first target group mentioned in my case, it's like Phoenix-TG and whatever the machine is there. And then if it is like slash app 2, route the traffic to my second target group, which is like Phoenix TG app 2. Okay, that is what I want to achieve here. Let me go to my load balancer. So I know already the load balancer is created and the listener section is there. You click the listener from the, let me go slowly. Let me come to the listener section, and then there is only one listener here. Um, so I just click the listener, and then it took me to the listener sections, and where I'm going to add rules here. This is how you are going to play around. Okay, if I come add listener, uh, it is still stuck to the same listener. There are different conditions are there. If you want to like host header means like if you are going to change the domain name for this one, or like you have to do some query strings or source IP. So any conditions like in from this domain name, this is my load balancer domain name. So uh, I'm going to pass and condition. If it is like slash upon route to this target group, that's what I want to go achieve. Like that, you can do some query strings. Query string means you after you might have seen after your URL, you might have seen some question marks. That is what we see. We always call query strings. After question mark, there will be some key value pair. Based on that this pairing will occurs. Um, and then this HTTP header, because there are a lot of HTTP headers would be there. So if it is if you are accessing some DNS, so multiple HTTP headers will be passed. You based on that you have to pass or not. So I'm just going to stick with path here, and my path is like app one slash star. I'm just giving like app one slash star. So whatever is it has to go to the first application, then forward to the target group is there, and I'm choosing the target group as the first target group, Phoenix TG. And then in the next step it will ask me priority. So based on the priority number only the routing will occur. So I'm going to you can choose any numbers. So and then I choose an 100 here. I just you can give any numbers, and then you give you create it. And I'm going to create one more rule. uh, Here I'm the condition for second application, app to star, and then forward the traffic to second machine, and then next, and then I'm giving this 1 or 10 something. Here you see. So now if you see here, this is the default value. When I created this machine, whenever you access that ELB DNS names, it will be routed to the default TG, which is like Phoenix TG. And then if it is like slash app one star, it goes to Phoenix TG. And then if it's like slash app two star, it goes to Phoenix TG app two, whatever the machines associated in the target groups. That is what I want to achieve here. And then I click next, and then I create. Now see, in my listener section, I have three rules now. The first rule is to like slash appointment go to this target group. The second rule is like app 2 means go to this Phoenix TG app 2, and then third rule is the default rule. If you don't give any path, it will be giving some default pages the first one machine. So if I go back to my now what I want to show is like if I do slash app one, you will be still able to see app one served from the, you see the URL has been changed, because while I was giving this custom script, the custom script which I put it under like slash var www.html slash app one, I added an index.html file. This one says app one served from the public API, this from the first machine I created. And then if I duplicate this tab, and then here if I instead of app one I give app 2 slash, then you see a different app 2 served from the 172.31.37.40. So if I go to my instance, Um, the TG, if you check the private IP here, it is like ends with 37.40. You see 37.80 integer, and then the default page should be always routed to the first page. So this how you will be installing multiple microservice in your application, and you do the path-based routing to route to different target groups. So uh, so let me come back to my slides and then scroll down. So we talked about target groups. Let me come and then query string we discussed. So after the DNS names, you just put it some question mark and then you give a key value pairs. Based on the key value pair means variable and values. Based on that, you route the traffic. So and then the network load balancers. Just we're seeing this thing and then uh, load classic load balancer. So we didn't talk about the session affinity. So the session affinity instance. So I consider like you are the client one and you always wanted to access the EC2 machine one. Why we enable the session affinity means whenever these people put some web applications, there will be some authentication base. Authentication means it will whenever you browse some application like facebook.com, it asking you username password, right? That what we'll do is like from the identity provided, it will get a token. Okay, if you route that machine, the first time the request can go to this first EC2 machine. If it goes to the next time, goes to the next EC2 machine, what will happen? The token which initially get generated, it becomes invalid. So for that case, what you have to do is if you needed session affinity, you can just while creating the load balancer itself, you had an option to enable the session affinity. You just enable it, so all the traffic from the client one always pass to the first EC2 machine. So that's why we need this session affinity. So by use there are different session affinity modes are available, either like application based or duration based. Mostly you can prefer this duration based cookies. So are these application cookies, which is like whenever the session affinity is created, what will happen? This key value pair has been moved to your first EC2 instance. From there, the routing will occurs. So cross load. So I will just explain these things. So I think it's already late. Give me like 5 to 10 minutes. I will explain some theoretical alone here. So this cross zone load balancing thing you need. Consider you have two availability zones: availability zone one and availability zone two. Okay, in application load balancer, what will happen if you have like 10 machines, but that 8 of the machines on the availability zone 2, that only 2 machines in the availability zone, how the traffic will be splitted is like it will split the traffic among all the machines equally. Okay, but whereas in without cross zone load balancer, what will happen? Yeah, so it will split the load based on the number of availability zone. It just splits to 50 because this is the half of the traffic goes to availability zone 1, half of the traffic goes to availability zone 2. But when you enable this cross zone, it checks how many machines are present and then divides by that. So this cross zone load balancing is actually enabled by default. You no need to do any changes when you create application load balancer, and no charges for this intra AZ data, because you are like splitting data between availability zones, right? So in AWS, each and everything is cost. If you are accessing data from one availability zone and to another means you have to pay data, so it's there like a lot of cost restrictions are there. But here there is no cost restriction. Application load balancer, this cross zone load balancing is already enabled, but for network load balancer, it is disabled. You while creating, you have to enable it. And then we already know about this SSL certificates, why we need in the front layer. Right now my listener was HTTP 80, but uh, we already seen how we will get this as a SSL certificates. The one method is like either you can use open SSL commands for any domain that you have. Like if you have any particular domain, you already got any domain like phoenix.phoenixtecho.com or something. For that phoenixtecho.com, you can generate a self-signed certificates by using this open SSL commands, and then you it will give you this PEM key and the key file. By using that, you can configure in your TLS sections. or the how the actual organization works means, so they will create a CSR first. CSR in means like certificate signing report, and then they submit to some certificate authority. They will validate it, and then they will be giving you the public keys. So you will be while creating the CSR itself. While creating a CSR, the output will be two things. One output is like your key file, that means the private key, and one more this CSR copy for you for yourself. So that's how we get the SSL certificates. So as I told in this class, so users will be accessing the load balancer and HTTPS, but inside your VPC you no need of HTTPS. All the encryption and decryption will be happens in the load balancer. That's one of the main application use of this load balancer. So if where you can, if you think of when we were creating this SSL certificate in Kubernetes, we had two things. One is dot key file, which is private file, and the public file we call PEM file or CRT. So there is something called AWS Certificate Manager. You can put your certificates there. Uh, you can just put the certificates, and then you can access from the load balancer. So I think that's it. I covered most of the things. So and then this auto scaling groups, we already seen the min capacity message, decide, and this launch template functionality, and then we were seeing the scaling policies, right? While creating auto scaling groups, the like target tracking scale is here, simple scaling, and there was a scaling that available. It's not available now. I'm not sure. There is something called scheduled scaling. So we just found like two scaling, simple scaling, like if it is like if it is more than 70%, scale it. Scale one more instance. Target tracking scaling means we choose, it will always try to achieve like maintain your overall CPU utilization at the 50% or 40% where you need. That is what we call target tracking scaling, and there is something called simple scaling. Right now, this only these two options are available in the ASG when we created. There was one option previously available, so something called scheduled, because it's a Christmas time, yeah, or if it is like some special holidays, like some New Year time, or like some many special occasions. If you think that, like if you consider like this Amazon Prime Day, right? That in Amazon Prime Days, many people are going to use that. Those times and all, they would be scaling up. They would be like, instead of running like five EC2 machine, they will be always running it in the higher instance. That is what we call predictive scaling. So, and then that's it. And then related to auto scaling groups, I just want to give something. So whenever an auto scaling happened, consider like one EC2 instance is running, when it added one more EC2 instance, so it will if the CPU drops down, if the CPU overall average utilization is 50%, if it is getting dropped to below 40 or 30, it will not scale down immediately. There is something called cooldown period. It will take at least 5 minutes for after scaling up, like after it added one more EC2 instance, it will wait for at least 30 seconds, and then only it will scale down. So that is what we call cooldown period in auto scaling. So I just covered, I think I covered a lot of things today. So launch template, target groups, load balancers, and then path-based routings. So any doubts?